let's solve x cubed plus 3x squared minus 6x minus 18 equals 0. This is a degree 3 polynomial, and it has 4 terms. So the strategy we're going to try is factoring by grouping. We're going to create our 2 groups, and we're going to find the greatest common factor between each group. So between the first 2 terms, we'll factor out an x squared, and we're left with the factor x plus 3. Between the second 2 terms, they both have a negative 6 in common, and then we're left with the factor again, x plus 3. Which means factoring by grouping worked out because I now have a common factor with these 2 terms. I can factor out the binomial x plus 3. So I'm going to have x plus 3 times what's left over from the first term is an x squared, and what's left from the second term is a minus 6. So I have x squared minus 6 as the second factor, equal to 0. So now that I have factors set equal to 0, I can use the zero product property. So I have x plus 3 is equal to 0, x squared minus 6 is equal to 0. So x plus 3 equals 0. I can subtract 3 to the other side. X is equal to negative 3. And in this quadratic equation, since there's only one term involving x, I can add the 6 to the other side. So x squared is equal to 6. And then I can take the square root of both sides, but I am going to get out plus or minus the square root of 6. So the square root and the square simplify to just x. So I get plus or minus the square root of 6. X is equal to negative 3. Now let's solve 3x cubed minus x equals 0. Here we have this higher degree polynomial, x to the third. There's only 2 terms, so I can factor out the GCF. I can take out an x, and I'm left with x times the quantity 3x squared minus 1 is equal to 0. Now that I have factors, I can set each factor equal to 0. I have x equals 0, and 3x squared minus 1 is equal to 0. So here's one of my solutions, x equals 0. Here I have 3x squared plus 1 equals 0. I can work to isolate the x in this one term here. I can add the 1 to the other side. I can divide by 3, so I get x squared is equal to 1/3. And then I can take the square root of both sides, but I'm going to get plus or minus the square root of 1/3. So that's x equals plus or minus the square root of 1 is 1, and then the square root of 3 I'm going to leave in the denominator. So here's my answer, but let's go ahead and eliminate the radical in the denominator by rationalizing. We'll multiply the top and bottom by the square root of 3. So the square root of 3 over the square root of 3 is just 1, and this allows me to rewrite it so that my answer is plus or minus the square root of 3 over 3. So here are 2 additional solutions. Now let's solve 4x to the 4th minus x squared minus 5 equals 0. This is a degree 4 polynomial equation, and the way we're going to be able to solve this is by recognizing the left side is in quadratic form. So it's not a quadratic equation, it's not a degree 2 polynomial, but it has that form. And we can recognize that if we rewrite it as 4 times the quantity x squared squared minus x squared all to the first minus 5 is equal to 0. And so we will be able to see it even more clearly if we go ahead and replace each of these x squareds with a single variable. So we're going to do a little substitution. We're going to let y equal x squared for a moment. So then this equation becomes 4y squared minus y to the first minus 5 is equal to 0. So now we can really see how this is in quadratic form. And we can factor this quadratic now. After a little bit of guess and check, here's what we would arrive at. We would get 4y minus 5 times y plus 1. is equal to 0. So if we check that, 4y times y is 4y squared. Multiplying 4y times 1, that's 4y. Negative 5 times y, negative 5y plus 4y is negative y. And negative 5 times positive 1 is negative 5. So this does work out. And so now that we have two factors set equal to 0, I can use the zero product property. But we weren't originally in the variable y, we were in the variable x. So let's go ahead and substitute x squared back in for y. So what we have is we have 4x squared minus 5, all as one factor, and then quantity x squared plus 1 as another factor. So now we can go ahead and set each of these factors equal to 0. 4x squared minus 5 equals 0, and x squared plus 1 is equal to 0. So let's go ahead and take that work up here. So 4x squared minus 5 equals 0. We'd add the 5 to the other side. 4x squared is equal to 5. Divide by 4, so we get x squared is equal to 5/4. Square rooting both sides, we get x equals plus or minus the square root of 5 over 2. So if I take the square root of 5, I just have to leave it as the square root of 5, but the square root of 4 is 2. And plus or minus because we took the even root of both sides. So here are two solutions. And now, looking at x squared plus 1 is equal to 0, this is not going to have any real solutions. So there's no number x that I can plug in and square and then add 1 to it that's ever going to equal 0. This left side is always positive. So this has no real solutions. If you attempted to solve it, you would get only imaginary solutions. So here are my two answers to this degree 4 polynomial equation.